Well, hello everyone. In this video lecture, we'll be solving problem number 1.140 of the book Problems in General Physics by IE Irodov. Without further ado, let's get right to it. So the question says, a small bar A resting on a smooth horizontal plane is attached by threads to a point P and by means of a weightless pulley to a weight B possessing the same mass as the bar itself. So bars A and B have the same mass m. Let's say m. Besides, the bar is also attached to a point O by means of a light non-deformed spring of length L0, which is 50 centimeter. L0 is 50 centimeter, and stiffness K of the spring is 5 mg by L0, which is given in the question, where m is the mass of the bar. The thread PA having been burned at t is equal to 0, this is the system, t is equal to 0, at t is equal to t, after the thread is burned, the system looks like this. The spring is elongated and the bar A, travels a distance of h, while the bar B descends the same distance h, as no other external forces are acting on it. The thread PA having been burned, the bar starts moving. The system is in motion. Find its velocity at the moment when it is breaking off the plane. So at the moment the bar A breaks off the plane, the condition is n equals 0. Contact force becomes 0 as the block is lifted up by the spring, with the help of the spring, and the system stops working, stops in motion, stops working. At that point, at that moment, we have to find velocity. Find its velocity at the moment when it's breaking off the plane. So let's start solving. As we can see, it forms a triangle here. Triangle perpendicular equal to L0, the base h, and the angle theta. Spring forms an angle theta. Therefore, tan theta equals h by L0, which gives us h equals L0 tan theta. So we have a value of h, which is L0 tan theta. Now let's write the dynamic equations. Now we can see that this is the normal force, this is mg to weight, this is the tension of the rope, and this is the spring force K delta L. Therefore, and this makes an angle theta, as this is theta. Therefore, N plus K L naught, K delta L cos theta along the vertical axis, that is y axis, K delta L cos theta equals mg. This is our first equation. Now another triangle forms. This triangle. This. Let's name it U. The length of the elongated spring BU, and this is L0, the previous length of the spring L0, and this is theta. Therefore, U cos theta equals L0, which gives us U, which is equal to L0 sec theta, and we know that U is equal to L0 plus delta L, from which we'll get the value of delta L, that is L0 sec theta minus 1. So putting this value in this equation in place of delta L, we get n plus k L naught sec theta minus 1 equals, cos theta, we forgot cos theta, equals mg. At the point of breaking of the plane, n equals 0. So putting this value, we get kn naught sec theta minus 1 cos theta equals mg. This is a second equation. Now putting the value of k, that is 5 mg by L naught sec theta minus 5 mg by L naught cos theta. We again forgot cos theta out here. It will cancel out cos theta. L naught cancels out. Equals mg. Rubbing it off. So 5 mg minus 5 mg cos theta equals mg, of which we get cos theta is equal to 4 mg by 5 mg, which is 4 by 5, the value of cos theta. Can we bring it off? Now in a triangle, a right angle triangle, this is theta, cos theta, as we got 4 by 5, the base 4, hypotenuse 5, we get the value of the perpendicular, which is 3. Now using the mechanical energy conservation law, as we saw earlier, that there is no external force acting on the system, therefore the change in kinetic energy plus the change in potential energy of the system is equal to 0. Therefore, the velocities of bar A and bar B will be equal as there are no external forces acting on it. Therefore, twice half mv squared, the kinetic energy of both the bars added together, plus the potential energy of the spring k n naught square sec theta minus 1 whole square, minus, as it is below the reference line, this is h, minus mg h equals to 0. Therefore mv square plus half 5 mg L naught sec theta minus 1 whole square minus mg, value of L naught, let's put the value of h in this equation, L naught tan theta, the value of h in this equation, the conservation law, which is equal to 0. Therefore, solving it, we get mv squared plus half 5 mg L naught 1 by 16 minus mg L naught 3 by 4 is equal to 0. The value of tan theta, this, as we discussed earlier, from here tan theta is equal to 3 by 4. Solving it further, we get mv square equals to mg L naught 3 by 4 minus 5 by 32 mg L naught. We also put the value of sec theta, that is 5 by 4, as cos theta equals to 4 by 5. Now mv square equals mg L naught 24 minus 5 divided by 22, which is v is equal to mv square equals to mg L naught 19 by 32. Sorry. Therefore, the mass gets cancelled. For v equals root over 19g L naught divided by 32. This is our final equation. On substituting the values of L naught and g, we get 1.7 meter per second. This is our final answer. Thank you for watching the video, and if you like the video, please don't forget to subscribe, like, share, and also comment in the comment section below. Thank you.